Hello, welcome back to the video lecture series on statistics for machine learning. We are going through the different measures or rather the characteristics of a set of observations, right? How can we find out the characteristics? So first of all, we have seen how central tendency can help us find out the characteristics. And what's a central tendency? A typical value representing a whole set of observations, right? So if I have a set of observations and I want to represent that set of observations by one representative value, so that's the value, that's the central tendency that we find out, right? So mean, median, mode are the three measures of central tendency that we have seen, and we can use any one of those measures as a value to represent the whole set of observations. Other than that, there is one more very critical characteristic, or rather critical measure to find out the characteristic of data, and that is the measure of dispersion. And what does it tell? It tells us the degree of heterogeneity in a specific data set. You can also think of homogeneity, right? So higher is the value of dispersion, we say that more heterogeneous is the data. And what do we mean by heterogeneous? We mean that from the representative or the central value, it is more dispersed or it is more spread out, right? That's what we say. Now, if I look at the same set of data, or rather same set of observations that we were looking in the past lecture, right? This is the number of goals that are being scored by a set of players in a tournament, right? Now, what we saw, the number of goals, if we do a mean, we saw that the mean is coming out as 14, right? So we say that 14 is that central value. Now, say, look at one more set of observations. Say this is the set of observations 2. You'll see that though the values of the different observations are different, still the mean value or the central value is coming as same, 40. Now, in that case, how can you discriminate, or how can you say, or rather, what is the basis to say that the two data sets are different, the two sets of observations are different? In this particular case, we have to use the measures of dispersion. And the first fundamental measure of dispersion is what we say is known as the standard deviation, right? So standard deviation is one basic measure of dispersion. How do we find out the standard deviation? That is very simple. Let's just put the individual values of xi's one after another, right? Let me just do something. Let me pull out a different page, and I have the xi's as one particular column, and then I have already calculated the x bar, and that is 14. I calculate then the xi minus x bar. Okay, that is the next thing that I calculate, and then I calculate the xi, or rather xi minus x bar square, the whole square. Okay, I do that. So what about the xi for the first distribution? 11, 12, 12, 13, 14, 14. So I just put it down here: 11, 12, 12, 13, 13, 14, 14. Then I have 15, 15. I have one more 15, and then I have 119. So this is the for the first set of observations, right? And the x bar, we know it is 14, right? X bar is 14. So 11 minus 14 is what? Minus 3. Minus 3. Then 12 minus 14, minus 2, right? Then again I have minus 2. Then I have 13 minus 14, minus 1. 14 minus 14 is 0. 14 minus 14 is 0. 15 minus 14 is 1, 1, 1. And 19 minus 14 is how much? It is 5, right? 19 minus 14 is 5. So if I just square them, this is coming as 9, 4, 4, 1, 1, 1, 1, and 25. So what is the total value coming as? 9 plus 4, 4, 13 plus 4, 17, 18, 19, 20, 21, and 21 plus 25 is 46, right? It's coming as 46. Now, 46. What is the formula for standard deviation? Standard deviation is equal to root over of 1 by n, and n is the total number of observations, into xi or xi minus x bar square. Okay, and we have a summation here. So each of the xi minus x bar, we do a summation. So what is the summation coming as? The summation is coming as 46. So how do I put it here? So root over of 46 divided by 10. So root over of 4.6. That is what is coming as. And if I do a root over of that, what will it come as? So let me do just a quick calculation of this. So if I do a 4.6, 4.6, and root over of that is coming as 2.14. So roughly we get a 2.1. This is coming as the standard deviation for the first set of observations, right? Now let's do the same thing for the second set of observations, right? So again, I have the xi, okay, and I have the xi minus x bar, okay, and I have the xi minus x bar square of that, right? I do the same thing, right? And the values here are a bit different, right? What are the values? 11, 12, 13, 14, 15. Again, I have a 15. Then I have a 16, 17, 18, and I have a 19. I have a 19. Now if I do it, the same xi minus x bar is also 14 here. If I do the same thing, so minus 4, minus 3, sorry, minus 3, minus 2, minus 1, 0, 1, 1, 2, 3, 4, and 5. If I do a square of that, 9, then 4, 1, 1, 1, 4, 9, 16, and 25. Now if I do a summation of xi minus x bar square, what does it come to? So 9 plus 3 is 13, 14, 15, 16, 20, 29. 29 plus 6 is 35, 45, 50, 70. So I get a 70. And what is the standard deviation here? SD is going to be is equal to root over of 70 divided by 10, because xi minus x bar square summation of that is 70. So this is root over of 7, which is going to be definitely more than 2.14, right? So let's just do a quick math. So if I do a quick math, so 7 and then I do a root over, it's coming as 2.64. So 2.6. So obviously we can say that compared to this particular set of records, so this one has a standard deviation of 2.6, whereas the first one has a standard deviation of 2.1. So obviously the first set of observations has more has the observations more spread out than the second set of records, right? So this is the standard deviation. This is the most common measure that we use in statistics. This is the sigma. The square of sigma, or the standard deviation square, is known as variance. So we often also use the term variance instead of standard deviation. Like this, we can also use some other measure like the mean deviation, which is basically nothing but if I do a sigma of xi minus x bar, summation of xi minus x bar, but absolute value of that, instead of squared value we do the absolute value, and then divided by n, then that's known as the mean deviation, right? And there is one more concept, which is the concept of quartile, or we can use that as a quartile deviation, right? So we will look into that concept in the next lecture. Thank you. Stay tuned.